Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, so now we are going to discuss about next topic, which is Kubernetes storage. So far we have completed the pod, which was the compute service of Kubernetes. Then we will also talk about the service, which is the in DNS service, okay, for the Kubernetes. Now we're going to talk about the Kubernetes storage, and then after that we'll talk about the networking also, and then security also, and then after that all the remaining topics whatever you have. Okay, so let's get started with the service. Kubernetes storage. So what is a Kubernetes storage? So what problem you are trying to solve? The problem is very simple. Anything which is getting stored inside a container, anything during the runtime, inside a pod, you know that container pod, all these relationship you know. So I'm not going to repeat the same thing again and again, but I expect you to know that or remember that. You must be you are having very good memory, so I have observed that one also. So anything you store in the container, those are ephemeral. Ephemeral means temporary. The moment the pod get deleted, I mean replaced, then you lost the data. So you lost the data, and that's the problem here. You lose the data, and that is the problem. The solution is like what we want actually. Even the pod is going and recreating, replacing, restarting. I mean, not restarting. I would say like terminating and then creating it. The data should not be lost. Data should not be lost. So what to do in this case? And that is what we are trying to solve in this session. The question is, how does these storage volumes are handled inside a Kubernetes cluster? We need to know. How can data persist beyond the life cycle? We want to know. Beyond pod life cycle means pod life means pod is gone, data should not go. How can containers share the files between? How can containers share files between containers in a pod? How can we have it? How can a container share files between containers in a pod? Okay, so these are the questions we are trying to solve. So are you comfortable with these questions? Can we move on? Everyone?
Yes.
In the chat window, can you please say yes? Okay, great. So guys, let's get started. So look at this here. This is the complete ecosystem of Kubernetes. So the base layer, we have a storage, which I'm discussing now. On top of that, we have a pod, which is a compute unit, which you know that. Orchestration is done by deployment, because deployment, earlier it was a replication controller. So I have not modified the images since many months actually. So it's been a year, I guess. So replication controller will replace with the deployment. Then HPA, horizontal pod autoscaler. This I did not talk about it. I'll talk about it. And then services. So services is done. Replication controller is, I mean, deployment is done. Pod is done. Now we have to talk about HPA and storage. Two more things which is not here: networking and security. So these are the things. Anyways, I will talk about it. Okay. So we are focusing on the storage. So how does Kubernetes communicate with the storage? That's the first question you should be having in your mind. How the Kubernetes platform communicate with the storage technology? And the answer is volume plugins. Okay, volume plugins. Volume plugins, with the help of volume plugin, Kubernetes interact with the storage, external storage. How? So basically, Kubernetes uses control plane, which is like a master interfaces to communicate with the volume plugin. These interfaces link Kubernetes with the external storage. These external storage solution linked to the Kubernetes are called volume plugins. Yes. Third statement, these external storage solutions linked to the Kubernetes are called volume plugins. That means in today's world, there are so many types of storage you have. So many types of storage you have. So these storage linked to Kubernetes through the volume plugins. So what exactly volume plugins are? So volume plugins enable abstracting storage and grant storage portability. So volume plugins, which is there in the Kubernetes cluster control plane, helps you to facilitate the access and then portability of the storage, different external storage for the Kubernetes cluster. So volume plugins are important. Okay, so the Kubernetes volumes plugin have the capability to provision storage for you. Yes, these plugins can also provision a storage for you. The AWS plugin can, for instance, provision storage for you by creating a volumes in AWS before attaching them to a node. So it can be done through AWS plugin. AWS plugin is one of the plugins, volume plugins, which can help you to attach the storage of AWS to the Kubernetes platform. Okay, so look at this here. Volumes. What is the volumes? So running application with the states which require the volumes. So volumes in Kubernetes allows you to store data outside of the container. Yes, understand that. Volumes in Kubernetes allows you to store data outside of the container. So when the container stop, all the data of the container itself is lost. But because of this volume is outside of the container, it is not lost. Whereas persistent volume, we call it in short PV, all the time I'll be using PV, persistent volume. In Kubernetes, allows you to attach a volume to a container that will exist even though container stops. So see here, understand that. Volumes in the Kubernetes allow you to store the data outside of the container. So where even though container stops, all the data is remain same, not lost. PVs in Kubernetes allow you to attach a volume to a container that will exist even that when the container stops. That means PV is the solution. Volumes are new since June 2016 release in Kubernetes. This image is very important. Look at this. Very important. I would ask you to spend some time here with this and understand this. Look at this very carefully. Look at the arrow, understand that. I'll explain it to you. So now understand that, guys. There is a two arrow, operates on and part of. Now see here, look at this here. Volume is a part of the pod. Look at this. Volume is a part of the pod. And when the volume is a part of the pod, the same volumes can be accessed throughout each container of the pod. Understand that. Whereas container is a part of the pod and pod is a part of the namespace, which you know that. Now you see that here, containers or volumes operates on with the help of secret. Now what is a secret? So here you see volumes operates on secret. Now what is a secret? That I will not confuse you the too many things. but secret is a part of the namespace. So that operates on secret related things. We'll talk about it at the end of it. Okay. So in this image, volume is a part of the pod. Volumes get attached to the container. Volume can get attached to the any number of containers inside the pod, anywhere. Pod is a part of the namespace, and this is what it is. Okay, look at this. Do you remember the explain command? Here you have a 3 volumes attached to the pod. 3 volumes. Here you have a 3 volumes attached to the pod. But if you look at it very carefully, the first volume, look at the first volume and the arrow. The first volume inside a container is mapped to the var apple, and the second container is mapped to the var primary. So yes, you can mount it inside a container at the different path of a volume which is attached to the pod. Now how can you declare a volume to the pod? So here you have a field called pod.spec.volumes. That is a field which we are using for assigning the volume to the pod. Now you want to allocate that volume which is assigned to the pod to the container, mount in the container, then you use the pod.spec.containers.volume mounts. This is the field you use it. Okay, so guys, explain command, if you remember, you can correlate with that particular field. That way you get it. So guys, did you understand this image? Did you understand this? Any question? Any questions, guys? Are you there?
Yeah, no, Rajesh. Yeah.
Okay, let's move on, guys. Look at this, guys. Here, this is the pod. I don't think so you'll find difficulties to understand. Now here, look at this very simple thing. It's just a pod. You know that you have created it. Here the pod with the one container. The container image is Redis. Now if you look at this here, pod.spec.volumes. Look at this here. Pod.spec.volumes. What is that? The name of the volume is test volume. Now that plugin name is host path. That's a plugin name. Host path is a plugin name. I told you, right? Kubernetes understand external storage with the help of volume plugin. There are so many kind of plugins are there. Host path is one of them. Host path, and host path plugin allows you to share the same host path, allow you to share the path in the same host where the pod is running. The location which is root test vol. Okay, so this is the way you can declare the pod. So here volume is a part of the pod, but the same volume test-vol you are using inside a container. So through what? pod.spec.containers.volume mounts. Look at this, volume mounts. And here you are using name of the volume test vol mounting at the inside a container at the test mnt. Guys, are you comfortable with this image? This is one of the plugin we are using. Guys,
Rajesh, like volumes name and volumes mount name should be same.
Yeah, volume name and see here, whatever the volume you attach to the pod, the same name you are going to mount it inside a container. No? That's the reason test vol is same. It has to be same. But inside a container you are mounting. See, mount path is inside a container, whereas test-vol is a place where the volume is running, the host machine location. Getting my points, guys?
Meaning, if I inside the container, if I cd to test mount, I can see the contents in the test volume.
Wonderful. You can see inside a container that location, and same content you can see in the host machine of that particular pod in the root test vol, because it's mounted. The here volume plugin is what is that? Host path. Host path. Got it, guys? Understood? Any confusion? Any doubts? Please do let me know. I'll help you. No? Let's move on. Guys, look at one more image. See here. Look at this here. In a cluster, you have a two node, node 1 and node 2. Look at this. In a node 1, you have one pod is running. My app pod is running. What has happened? My app is using the volumes, which is EBS storage, which is a one plugin. Okay, AWS is a plugin which allows you to attach EBS storage to the pod. Now you understand the nature of the EBS, right? You guys are comfortable with the AWS storage? Any inputs? You guys are comfortable with it?
No, or at least I'm not comfortable.
Okay, so there are different kind of storage in AWS we have. One is like a EBS, which is called block storage. I'll tell you in a simple way. Block storage means the same storage which you attach to the laptop, no, through serial bus is kind of things. Block storage. Laptop, the storage which you get it's a block storage. So basically, when can you attach that same storage to some other laptop same time to laptop? No, you cannot use it. One storage, one laptop. That's called a block storage. So EBS has the same property. You cannot attach two compute unit to the same volumes. Okay, say EBS storage. Now there is one more called EFS. EFS means elastic file storage. That is something similar to network storage that can be accessible over the IP address. There is one object storage which you have, S3 we call it. Okay, so S3 is like something like if I correlate Google Drive is S3. Okay, so different technologies are there, but here I'm talking about the AWS storage, which is a EBS storage. Okay, so EBS storage can mount it to the one compute unit, which is a pod. It can be VM, it can be physical machine also at one at a time only. You cannot mount multiple. Okay, so because of the nature of the storage. Okay, makes sense, guys? Are you able to understand that?
Yes.
Yeah, so now what happened, that pod get disappeared because of some reason, node get disappeared. So it will deployment, you know that it will create a replacement pod. It will create immediately, and now you got the pod in the second node, and same EBS storage you got linked to it. So this is the power of volume. So here you see storage portability. You can experience the storage portability here. Okay, so this is the way pod is gone, storage is still there. So this is the power of AWS. I mean, this is the power of plugin, volume plugin. Different kind of plugins are there. One example I showed you, host path plugin. Another one is cloud plugin, AWS cloud plugin, and stuff like that. Look at this. So how this whole anatomy works. So storage, there are different kind of storage. We have block storage, object storage, file storage. Now this storage you can get it on the any platform. Like you can set it up in your within a company organizations also, or you can set it up in the AWS, Azure, Google Cloud, VMware, anywhere. All these things you can get it. Now storage is understood. These are the external storage. Okay, understood by control plane, which is Kubernetes master, through the help with the help of the plugin. Okay, that arrow which you see between the storage and the Kubernetes master is the plugin. So through the plugin, through the interface, they understand the external storage, and then they power it. Then Kubernetes master control plane power all of your pod. The pod, it can be Postgres pod, MySQL pod, HTTP pod. So why I'm talking about all these pods? Because pods only there you need the persistency, because pod is a compute unit. So that's where you need a persistency. Okay, so different kind of volumes you can mount at attached to the pod. EBS storage, which I showed you, Google Cloud, Google Disk, NFS, Ceph, Azure Disk. So many technologies are there in today's world. So everything is been addressable through the volume plugins. So guys, volumes in fact are two types of volumes. Hello.
Yeah, we can hear you.
Okay, guys, keep telling me because here I see that message on my screen. You got disconnected or something like that. So I don't know what has happened suddenly, and suddenly I see that disconnected. So please keep in sync. So volume itself, there are two types of volumes. One is inferal, another one is durable. So what is the inferal? Inferal is like a same life cycle as pod. That means inferal volume, when you attach to the pod, the volume will be there, exist as long as the pod is there. But if the pod is gone, the volume is gone. So here, this is called inferal. This is the not something which you are looking for. You are looking for durable volumes. Durable volumes like a beyond the pod lifetime. That means pod is gone, pod is deleted or whatever it is, the volume is still there. So you want the durable. So that's the thing. With that, let's understand types of volume which I've been talking about. So look at this here. These are the types of volumes. Okay. Some of the types. One of the types which I showed you, AWS Elastic Block Storage. There's a second row. If you see that sixth one, host path, which I was showing one example of it. But here you have Azure also, SAP also, Cinder also, Mtdr also, local also, Git repo also. Many kind of storage plugins are there, which basically help Kubernetes to understand the external storage and then get you that pod available to the pod available. Now, if you want to categorize this one into the storage category, then I think this image is good. Look at this. Host-based volumes, Mtdr and host path. These are the plugins. Block storage volumes, EBS, GCE disk, Azure disk, and vSphere volumes. These are the block storage. NFS, like a distributed file system like NFS, Chef, Cluster, Amazon EFS, and stuff like that. And so many other things also. So these are the category wise, the storage plugins, volume plugins we have, which you can use it. Now, if you want to see the list of all, you can revisit the last URL, which you can see on the screen, and go and check it out. So this is all, by the way. One or two maybe addition will be there, which is something like from last 6 months, maybe. So it's like this. Now the question is, everything we did talk about it, but the question is, how can we provision the volumes? How can we provision the volumes for the Kubernetes? What is the process? What is the process to provision a volume for the Kubernetes cluster? What is the process? So guys, there are two processes. There are two things. One is static provisioning, one is a dynamic provisioning. Okay. So in order to use that any volumes beyond the pod lifecycle, you have to follow four processes: provisioning, binding, using, reclaiming. Again, repeat this: provisioning, binding, using, reclaiming. Provisioning means make it available the storage for the cluster, Kubernetes cluster. Binding means bind it to the pod, bind it, make it available. Using means using the containers, pod, whatever it is. And reclaiming means what after that using. What do you want? Reclaim it or leave it as it is, whatever it is. So I'm talking about the provisioning here. So guys, there are two types of provisioning what we have: static provisioning, dynamic provisioning. So static provisioning means what? Static provisioning means PV need to be created before PVC. Now, what is a PV and what is a PVC? In short, let me tell you. PV is persistent volume, which is persistent volume need to be created before PVC. So PVC means persistent volume claim. Okay, claim. So what is this? So here what static provisioning is being sent before binding it. PVC is a binding, okay? Before binding it to the pod, okay? Before binding it to the pod, you have to provision PV. It has to be available. PV has to be available. For example, let me put it in a simple way, static way, right? So I'm doing static things. So provisioning and binding. So I'll go to AWS here and here. Look at this. I go to the, I'm just trying to correlate so you understand the concept well. Okay, because when I used to get into this topic, even I had that challenges. So I need a visualization all the time. Okay, so for that same visualization, I want to use it. So right now you see here, AWS has so much of volumes available. See, AWS is the platform. Kubernetes is also a platform. AWS is a platform. Kubernetes is also a platform. So when AWS is having volume that is already existed, who's made it available? Who's made it available? Someone or from the Amazon team. I don't care about that, but I am using it. Can I create a volume? This creating a volume means I am binding this. How much you want? 1 GB. And create a volume. So this I did, I created a volume. See here, this volume, look at this here. I created a volume. What this volume process is called? This process is called, as per the image, binding. Binding. Binding means PVC, persistent volume claim. Binding PVC. Binding PVC. So here it's saying provisioning has to be available. PV need to be available. So who made this storage for us? So I am going to use it, binding it. So that provisioning PV is done by Amazon team. So it is available for me and I got 1 GB storage. So that's what I'm trying to tell you here. In the Kubernetes also, someone has to make it storage available. So other people will bind it. PVC. Guys, are you able to understand this concept?
Yes.
Everyone? Everyone, guys? What is the PV and what is the PVC? PV is basically having the storage available, but I am going to create it. That's called PVC. Okay, now I will delete this. This is called reclaimation. I have not attached. I can attach the volume to the EC2. That's called binding, and that's called using. That's called using. And if I delete, that's called reclaiming it. Did you understand this process? Clear?
That's similar to the data store creation in vCenter.
Yeah. Same thing. Yes. Correct. Someone administrator will make it available. Then you will go and create a volume, then attach to the instance, and then use it. And after that, once your requirement is done, you will delete it or reclaim it or save it, whatever it is. Got it? Okay. So now I'm going to talk about provisioning. Provisioning, there are again two types. Provisioning is, who will be doing the provisioning? Administrator. Okay, of the Kubernetes cluster. They will make it available. So developer go and use it, bind it and use it. So here provisioning has to be done in a static way and dynamic way. Static way, that means PV need to be created before PVC. But what happens? That way it's costly. That way it's costly. So what about dynamic provisioning? Dynamic provisioning means when you have a requirement, then only you create a PV. That means if I have a requirement, think about it. If I have a requirement, then this create will happen and then attach will happen. So that way I'll have to pay for only for the duration of the uses. But if I made it available, then I'll be paying for AWS, right? Those storage I'll be paying for AWS. It's costly. So dynamic means,
to get our channel membership, click onto the join button, select the 399 plan and grow your skills immensely.
If you need it, then you go and get it. In advance, don't make it ready. But dynamic is little bit time consuming. Not, when I say time consuming, that means few seconds more than static. Static is costly. Got it? Got it, guys?
Yeah.
Okay, let's move on. So I hope you understand that you are doing nothing but as an administrator also, provisioning, binding, you'll be doing as a user, development, using, and stuff like that. So guys, these are the APIs we are going to use it in today's session in our storage. PV to create a PV, PVC to create a PVC, storage class for dynamic provisioning, volume and volume attachment for using, volume and volume attachment using. So look at this, provisioning, binding, using, reclaiming. Look at this here. Persistent volume PV, provisioning, PVC, binding, volume and volume mounts, using. Okay, reclaiming we are not discussing because ultimately you want the persistence. Okay, so in short, what is a PV? What is the difference between PV? PV means piece of a storage in a cluster which is already available, but PVC is basically requesting for a resources, requesting for the storage which you have from the PV. Okay, so PVC has to be requested from the PV, and PV will request, PV will create dynamically or static, depends on the requirement. Okay, so that is the one thing. Got it, guys?
Yes.
Yes.
Okay, so guys, how the flow will work? First, get your physical storage, then create a PV, then create a PVC, then use in the pod app. That's all. So physical storage, PV, PVC, and app. This is the flow. Now, physical storage. What is a physical storage? I'll just skip it. Too much of discussion. PV, I have explained it to you. Okay, please read this. It's a very helpful statements which we have. This is the PV. Now let me read you PVC. Please read this one also. Very important statement. Okay, can we move on, guys? Guys, can we move on?
Yes.
Yes.
So last slide, just please read it. Okay, so guys, this is the flow. Look at this. When you do the provisioning PV, create a PV, static provisioning, then what do you do? Look at the step number 1 done by administrator. Step number 1, PV created. Step number 2, it requests the physical storage. Then PVC happen by the user, and then PVC requests the PV, pool of PVs, and that is what it happens. So this is 1, 2, 3, 4. I'll just skip this detailed discussion. Look at this here. So in a different way, see here, when you want to create a pod, you requested the PVC. When you request the PVC look for the PV, available PVs, and this PVs, each PVs will attach to the one of the physical storage. Here in this image, EBS, AWS. Okay, this is the one. Now you see here, this is the whole layers of the storage. So here you have a physical storage and the bottom line. Okay, physical storage. Now on top of that we have a persistent volume. Okay, and on top of that persistent volume claim. Okay, so you have bottom line, you have physical storage on top of that persistent volume, on top of that persistent volume claim, and top of that mount points, and on top of that pods. So here PV, PVC, mount, and pods. So now how can you create a PV? That's the question. So who will create a PV? Administrator will create a PV of what? Kubernetes cluster. Now PVs can be created through the different technologies, and these PVs will be a pool. Okay, PVs will be a pool from the different technologies. It can be a object storage, file storage, or block storage, whatever it is. It will create a pool, and when you do the PVC, then you will look for the pool. So this is the image. Look at this very carefully. Just look at this. Step number 1. First, administrator made this PV available. Step number 2, request a PVC. This is called claim, PVC. Step number 2, you see that when you claim it, claim look for the PVs, pool of the PVs. If the PV is available, then respect happens. Claim request owner. Now look at this here. This is the complete picture. Look at this. Same image, little bit extension. So this is the complete flow for how this overall works. Step number 1, administrator will create a PV, pool of PVs from the different technologies. From that, user developers will claim during the creation of the pod deployment and all. He will create a PVC, and PVC will check the pool of the PVs, and then claim owner. When claim owner, then that volumes will get attached to the pod. See here, volume, point number 4, volumes get attached to the pod, and that volumes which is attached to the pod, you can mount inside a different container with different path, which I said, which I discussed already in starting itself. Did you understand this?
Yes.
Yes.
Okay, so this is the complete flow. So by the way, we will play the administrator role also, we will play developer roles also, and we'll create a PV, we'll create a PVC, we'll attach to the container, all the stuff like that. We'll do that. Okay, dynamic provisioning. Dynamic provisioning, what happens here? PVs, when the pod requests for the PVC do not check the pool because there's no pool available. So PV check, use the PV. Understand that PVC requests the storage class. Storage class is basically one of the API, resource API, which has a template to create a PV on demand. Okay, so when the PVC is requested, so PVC's request will be processed through storage class in terms of dynamic. And storage class you have a defined. Okay, if that PVC is requesting the PV through storage class, then they will create a PVs on behalf of you. So here manual work is not being done, automated work, but this is less costly, more efficient. Okay, in the PV's case, when you make it manual static provisioning, that is very costly because you have to make it available no matter whether you use it or not. But the disadvantage of this is like you have to wait for a little bit, few more seconds to get the PVs created and then attached to the pod. So this is called dynamic provisioning. This image is dynamic provisioning. In the dynamic provisioning, you use the storage class. Make sense, guys? Make sense, guys?
Yes. Yes.
Okay. So look at this dynamic. I'll not repeat the same thing. I'll just move on. I'll give you this. So yes, yeah, here static versus dynamic, whatever you want. So life cycle of volume and claim. So yep, this is the summary. You have to provision, then bind, then use it and reclaim it. Provision using static persistent volume, dynamic using storage class, binding PVC, using volume and volume mounts. You have seen the code itself, YAML code of the pod. And reclaiming after that, what if the pod is gone? What do you want? You want to retain the volume, delete or recycle? By default, it's a retain, but if you want to delete that, you can do that, and recycle also you can do that. So this is the entire life cycle of storage in Kubernetes. Okay. So any questions so far? So guys, these are the types, volume plugins types, which I discussed in the previous slides. So these are the different types which you have, which you can use it. So there is one empty dir is there, which I showed you. Host path is there, one example I showed you. Google Cloud, if you are on GC, you can use it. AWS, NFS, secret. Here, secret. I told you, right? Secret. I'll come back to later to you. So this is a secret, and PVC is there. So all these things are I'm going to discuss now. So as part of the sessions, I'll discuss about the empty dir. I'll discuss about the host path. I'll discuss about the NFS. I'll discuss about the secret, PV and PVC, and config map. Okay, so these are the one which I can set it up with the manual infrastructure. My Kubernetes, I set it up through manually, so they don't understand EBS, EFS and all cloud-based storage. So you'll have to do that manual NFS, host path, empty dir and all for the use cases. Now, what is the empty dir? So empty dir, in short, I'm just telling you, empty dir is a kind of volumes which is inferal volumes. Yes, which is inferal. Means this volume will be created in the same host where the pod is running. Let's understand that. These volumes will be created in the same host where the pod is running. Okay, but if the pod get deleted, the volumes will get empty also. That's the reason we call it empty dir. So please read this statement. It states an empty dir volume is the first created when a pod is assigned to a node and initially it's empty. That means it will get created when the pod is assigned to the pod is assigned to the node, and initially it's empty. Volume of a time reader that lasts for the life of the pod, even if the container terminates and restart. That means even container terminates or restart, the volume will be there, but if the pod is gone, the volume will be empty. So if the container in the pod crashes, the empty dir content is unaffected, but all the containers in the pod share use of the empty dir volumes. That we know that very well. So this is the empty dir in short. Now, which is the location? Look at the last line. Location of the empty dir will be on the host machine where the pod got created in this var lib kubelet pod ad volumes kubernetes. Okay, that's all. So again, some readings are there. I'll just skip it because I'll show you directly demo. Look at this. This is the empty dir. Read this code, then I'll explain it to you. Guys, did you understand the empty dir how to create? Can I show you the demo now?
Yes.
One more example, look at this. One more example. Okay, so can I start the demo? Any questions you have? This is another plugin which I'm going to discuss, and I'm going to show the demo. So first get the example code. So I need to copy the example code. It's a little bit slow. Why this is there? Should be fast, no? So guys, this is the URL, you can refer it for learning purpose for the future. Everything you have it here, but I'm going to copy the code here directly. Just okay. So I'm just going to copy the code. I'm putting in the notes also. It's a little slow today. I don't know what is happening. I cleaned it up yesterday. We had a hacking yesterday, so I had to revert back from the backup. Many people don't like this website, so they try to face off, deface this website. So here it is. So look at this, guys. If you have understood this image, this code, then I will run it. Please look at this. Not very difficult code. Only thing which I will change is I will change my image name here because I want my image, which is, I think I have it, and that is because in my image there's some utility which I can run it, and the demo will be smoother. And those utilities are this one here. So guys, are you comfortable with this code? Can I run it?
Yes.
Okay, let's go ahead. So now I'm going to use that host path itself. I mean, same place. So CentOS cdhp vi pod pod emptier. Let me name it emptier only. Emptier dot YAML. And what is the name? Test PT, right? So kubectl create -f emptier -n is equal to Rajesh. I created kubectl get pods -n is equal to Rajesh. See, here it is. Now inside, if I go inside a pod, so can I go inside the pod? How can I go inside the pod, guys? Any commands? Do you remember?
We need to get the IP value of that.
No. I want to go inside a pod. Why do we need IP address?
kubectl exec.
Yeah, you got it. So kubectl exec -it. Get a habit of all these commands. It will save lots of hours of you. Okay, guys, I'm inside this. Okay, did I do mistake? I've been bash. I forgot. See where I am. I'm inside a container. Okay, now can I check this inside a container? Do you have a cache or not? So look at this. CD cache. See, something is there. Can I write one file manually? Though application should write a file, but here for demo I'm writing DevOps school.txt. Okay, this file. I'll come out of it. Okay, now can I go in this path and check, do we have that location, that pod or not? So var leave kubelet pod and pod ID. Okay, so here cd permission denied, so sudo, can we do this? See here ls, where I am, sorry, I did not go, sorry. So but I should. Okay, sudo will not work. Sudo -s cd. So can we check now which pod? I think pod ID I did not noticed. So exit and kubectl get pod -n Rajesh and describe this pod. So kubectl describe pod, this pod -n is equal to Rajesh, and here what is a pod ID? Where is that? Locate this. Should be here only. Can we locate test container? Okay, I'm not able to locate right now. So
use -o void describe.
-o void. That's for the get, it works. Oh, wait a second. Let me
remove the describe.
Pod ID.
If you remove describe, make it get.
Get pod hyphen o wait, no, there's some other table. Just a
Hyphen
second.
O YAML will give
Pod,
token.
just a second, hold on, give me a second. How to get Kubernetes pod IT. This should be some command for it. See, so for that, pod ID is, I have to type this command. The command is, oh, there should be some simple command. No, it's very long command. So
Can you type kubectl get pods minus -o.
just again, sir, I'll write it. Yeah, tell me what you want to write.
Kubectl get pods.
Kubectl get pods. It won't come that.
No. Kubectl get
Okay,
pods and minus -o namespace.
No, that will not come. That IP address won't come. Okay, here it says -n. Let's modify this line. And Rajesh. Okay, and where is the test PD? Okay, now metadata.uid, let it be. So this is the pod ID. Okay, but why it was not showing in the describe? I'm still okay. We'll check later. Okay, we'll check later. So you can also do like this, -o -o JSON, and here also you get a pod IP, pod ID somewhere. What is the here UID. Okay, so you can also do like this. Okay, so forget about that. Do we have that? So sudo -s, sudo -s, and here do you have this ID? The ID is 275. Oh, is this the one or something else? Did I notice? Guys, so sad. I did not
It
notice.
is something else.
Yeah, something else. Just a second, guys. Yeah.
So it is there ACB something. Fourth one.
Let's match, no? Check exit. Oh, no, not exit. Sudo -s ls. Go to that location. And do you have anything? Where is that? Where is that?
No.
Where? I can't locate. See here. Match this. Do we have?
No, it's not there.
No.
Not there. How come it's not there? Should be there, no, guys. I created a file also inside that, but it's not there. How come?
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Empty dars. You see the code again. Empty dars.
So the same namespace.
Data volumes.
Container is not running. Container is exited.
No. It's running. No, I showed you. No, that's, see here. Get pod. Just a second. Let me make it full screen because Rajesh, and here is running. See here. You want to list out here kubectl and kubectl exec this one, and what do you want? CA cache, right? See? Note. kubectl exec test pod ls. What is the mistake in this command? Okay, namespace is missed. No, see,
Yeah.
I have a problem remembering the namespace. The reason is, I'll tell you, namespace typically I embed in the kubeconfig only, so I don't have to type again and again. Okay, anyways, so why it's not there? Why it's not there? Any more clue? What do you think? Why it's not there? Where is this volumes which got created? Embedder. Any idea, guys? No problem. Please read one more time. Embedder. This is the embedder.
It will be on the worker
Please
node.
read one more time and tell me. Ah, yes.
Not.
Remember, the pod is getting created not in the master. I was in the master right now. It should be in a worker node, right? So I should do check in the worker node. kubectl get pods -o wide -n Rajesh, and here this guy, where is the test pd? Here it is. This got created in 243. So let me go to that particular node. So now I'm going to that particular node. So here, where is the 243? It's EC2 instance. Why is very slow? So see here, (243), not this. This is the one. So let's copy. I'm going to 243 now. New session. Auth. Mumbai PK. Yes. Here. CentOS sudo -s. Now can we go to that same location again? So I don't remember the path. This is the one. CD. Do you have so many things now? Can we search? That's a better option. CD. Do you have files? Inside that, there's one location which is called volumes kubernetes. So let's better search the file name. Find name DevOps something. It was there. I forgot that. See, DevOps school.txt. This file is there, right? Correct. So this file is there. Now here, what will happen? See here. This file is there. Find dot name DevOps star. See, that file is there. But what will happen is, you look at this. I'm deleting this time the pod. So here kubectl delete pod. What's the pod name? Test pd and -n is equal to Rajesh. I deleted, and now after this, see, volume gone. So this is the empty dir, guys. Empty dir has a inferal volumes. Did you understand that, all of you? All of you?
Yeah.
Now I'll talk about the solution for this problem. What should go? What should go on? It should be going, but the volume should not get deleted. So for that, solution is host path. In short, I'm telling you, host path will create a volume which will be persistent even the pod is gone beyond the pod life cycle. But there is a one disadvantage. This host path volume plugins will create a volumes in the same host where the initial the pod is running, and if the pod is getting created in the other node, then it's not portable. Then it is not portable. So portability here you won't get it. That's a major problem here. Okay, I would request you to please read this so you'll get some idea, more idea.
So when we created part for the first time without all these volume MTDRs and also that's the default behavior.
Yes, that's the default behavior. Now empty dir has a one advantage. Okay, empty dir. So when you create a pod without a volume specification, then there is no volume get created. So whatever is gets stored in the container, that is that's the storage whatever you have, container storage. Now container got restarted, you lose the changes. Even the pod is there, you lose the changes. But what happened? What advantage you have in the empty dir? Empty dir, the pod is there, container is there. Container got restarted, you won't lose the volume. Empty dir. But if the pod is gone, then you lose the volume of empty dir. So here initially first time when we create a pod without any volume, then empty dir when we create a pod volume, then the container get restarted, no problem. But pod got deleted, problem, volume got deleted. But in host path, that problem is solved of empty dir. In the host path, what will happen? The pod volume will be created, it will be stored also, the data will be stored also. Pod is gone, volume will not be deleted. But the problem here is, if the pod is created in the some other node, that volume is not portable. That is the problem. Getting my points, guys?
Yeah, okay.
Okay, so can I show you the demo directly?
Yes.
So here, host path, I'll just copy this code and I'll explain it to you. Look at this here. This is the pod. Here volume is plugin is host path. Host path at which location? Data directory. Directory create. If the directory is not exist, create it. Inside this volume, you are mounted inside the test PD. And then this is the second type. Any questions, guys?
I think the first line is missing, Rajesh. API
Which first?
version is missing.
Yeah. I'll copy this. Done. Yeah, guys. More question? Can I show you now? Okay. So now let's create it. Vi host path .yaml. Okay. Now here kubectl create -f host path -n Rajesh kubectl get pods. See, oh, sorry, get pods -n is equal to Rajesh. See here. What was the name? I forgot that. Test PD. This is the one. Now, where it got created, I want to know which one. See here. Test PD created in 105. 105 is another one. So 105. Can we write some files inside this? So where it got mounted? Test PD. So here kubectl exec test PD and touch test PD. One file I am writing. The file name is raju.txt. Raju.txt. This is the file. What happened?
Namespace.
Namespace.
So
Namespace.
sorry. Yeah, namespace. Why I forgot every time. So done, guys. There is no error. That is a warning. Okay. So can we check this? ls wrong command.
We should,
Yeah, raju.txt. So now you have it. This file is there, but which node? 105. Let's go and get it. 105. So 105 is should be here. This should be this one. Let's go and check this physically. It got created or not. Okay, so data. Let's look at this here, data directory now. See here, data directory. So cd data. Okay, see here. But what I'm going to do is I'm going to delete that pod. So can I delete that pod? So qctl delete pod test dot pd hyphen n is equal to Rajesh. Spelling mistake. I deleted this pod. Can we check that? See, data is still persistent. Now, what about if I recreate the same pod again? So let's create a recreate the same pod again. Create host path and get this. I'm hoping it should be creating another node, because if it's creating the same node, you'll get the same data. So it got created in the same node. So you'll get the same data actually. But did you understand the concept? Did you understand the concept?
Yes, yes.
Okay, so for fixing this, if you want to force some pods to create in the some specific node, you can use a node selector, code affinity, and all stuff like that. So many things are there, but this is the one. So guys, this is the one. Now second one, next one is the NFS and config map and secret and PV and PVC. That all will go in one way. So I'll talk about it. Now what I'm going to do, I'm going to show you the PV and PVC directly. So let's do that. So here, look at this PV and PVC. So you can create a PV using any technology, host path, NFS, what else? EBS, Azure Disk, many technologies, physical storage you can create it. Here, because host path we have accessible. So let me complete this demo and then I'll give you the lab for this. So this is the PV and PVC, PV, and it's a static one I'm showing you, PVC. Okay, so first thing we have to create a PV. Let me open up this URL. Just let it open. So guys, look at the code here. I'm giving you the code. PV conceptually you have understood. So you have to create a PV as the admin, PVC as a user, and you use it in the pod. This is a 3 YAML file. You have it. Same thing. I'm going to do that in front of you. So let it come. Yeah. So I'm going to copy this PV. So guys, this is the PV. Okay, why this is getting copied? So this is the PV. See, persistent volume. Look at this here. You are creating PV. This will be done by administrator. So he will. Right now we have a host path only. So they are creating PV with the host path. Here this can be any plugins which I showed you already. Okay. So this host path here where it should be TMP DevOps school. Okay. So in the any node wherever you run inside the TMP DevOps school. So this PV will be created. Of how much storage you will be occupying from this? 1 GB storage. Okay. And here you labeled with the type local. That means host path. Okay. Are you okay with this PV creation process? Here storage class name is manual. Are you okay with this?
Yes.
Okay, now I'll show you the PVC code. So here PVC code. PVC will be done by user. Okay, so don't mistake. See here, this is the PVC code. Here you are creating PVC, kind equal to PVC. Here kind equal to PVC. Here you are creating a PVC. So PVC, for that you need a PV. Understand that? For PV you need a PV. For PVC you need a PV. So any PV available, it will be bounded. So here you see PV. Again you are requesting 1 GB. Let's say you have a PV of 1 GB and you are requesting 2 GB. What will happen? Any idea? See, you have only one PV available for 1 GB, but you are asking for 2 GB. What will happen? Any idea? Go into the pending stage because the request is not honored. PVC request is not honored, so it will go into the pending stage. Are you getting points? It has to be respected. It should be equal to or lesser than that. PVC of PV should be equal to. So this is the PVC. PVC. What is the name of this? Again, storage class manual here. Now what you are requesting here? So 1 GB. So it will take this. It will request from the pool of the PVs. Okay, and after this, whatever the request, you can use that PV inside here. Look at this here. What happened? Look at the PVC. This is the one pod. This is my image, and you see here important thing here. Type become a PVC claim. What is the PVC name? PVC host path, which is here. Look at this, and you are mounting inside that this place. Guys, did you understand this now? This is the using of the PV and PVC. You all understood?
PV also have a mount point.
What is that?
Even PV also have a mount point. Like
No.
like some part. The above.
PV
Yes.
will have a physical. It will claim from the physical storage.
Oh,
This
okay.
depends on the volume plugin.
Okay.
So this is a plugin based on that they'll claim from the physical storage, but you will have to request it. This is called request. So this will be done by admin. This will be done by user. This will be done by user. Okay. So now I'll show you. Are you comfortable with the code?
Is there any mapping between PV and PVC?
So that's what I'm telling you again and again. So PV is a pool of resources for the cluster, and PV is requesting for one of the resources from that pool. For example, I'll tell you like this. Let's say you have a 10 laptop. So if you have a 10 laptop, if I'll ask you one laptop, you will give it to me. But if I'll ask you 11 laptop, will you give it to me? No. Then my request will go into the pending state. So it's like this. PV is a resources in the cluster, storage resources. So here also I created 1 GB. Why? See, I'll tell you here. Here I created 1 GB in AWS. Why I created 1 GB? Because it was available. If I created 16 TB, 17 TB, that's not available. So I'll not be able to do that because AWS supports only till 16 TB. So it's like this. It's a pool of resources. Pool. PB is a pool. Getting your points?
But actually, there are different kinds of PV, right? Here you used OSPath, so you can have any type of PV. So
You can.
actually,
This you can have it any type of PV, depends on the physical storage. If you're using host path, I use host path. If you're using EBS, you can use EBS. You can use NFS also. You can use EFS also. You can use Azure Disk also. Many different physical storage.
yeah,
Physical
but if
storage.
I have two different kinds of PV, and if I my claim I want to specify that type, I can't do that, right?
Yes. No, you can do that actually. So whenever you create a PV, PVC, sorry. Whenever you create a PV, you can have a selector option. You have here also we have it. I did not mention here. If you want to only specific PVs you wanted, then you can have a selector. So label selector, whatever you do here, you can write it. Let me show you some code actually, rather than talking. So here PVC based on selector. selector, and here look at this. So same way a service work, no, same way it will work. Look at this here. So here labeled, this is a PV, okay, created with this label, okay. Now they are PVC, they're selecting that, only select that volume which has a volume type SSD. That means this one. So this way also you can do. The selector play a very important role for many places. Make sense? Got it?
Yes, got it. Thank you.
Okay. So now I'm going to create. So rather than let me create a 2 PV, that way you will get confirmation what I'm talking about, the pool, meaning of the pool. So here is a host path and here is a host path 1. So I'll create a 2 PV. So let me create a 2 PV. So here I am going to my workstation and vi pv1.yaml, and PV is a specific namespace specific, guys, please mind it. pv2.yaml and done, guys. Okay, so pv1 is done, pv2 is done. Now kubectl create -f and pv1 -n is equal to Rajesh. Okay, PV is not a namespace, sorry, my bad. PV is a specific to the cluster. So here you created a cluster PV and PV2. PVC is related to the namespace. How can you see that? I told you that command in first day one only. So kubectl get PV. See here, 2 is there. Get PV -n also, if you do, you should see 2. See, so PV is for the cluster, entire cluster. Look at this here. Host path 1. This is the 2 PV available. Pool. This is the 2 pool I have got it from 1 GB for each one of these. It's a manual available, all these things. So can I do the binding and you see the magic? So I'll do the 2 binding just for the demo. Okay. So I'll do the 1 binding here 1 GB and another binding I'll do 5 GB. I don't have that any PV available with the 5 GB. Okay. So this is the PVC. Okay. So PVC vi pvc1.yaml, and here I did the PVC. Now PVC and PVC1 and PVC2 5 GB. Okay, vi pvc2.yaml, and here this is the code. Now can I run this kubectl create -p. PVC has to be at the namespace level, mind it. Okay, PVC kubectl PVC and -n is equal to Rajesh. And can I see that PV now? Okay, look at this PV, guys. Look at the PV here. See here. See, one is available, one is bounded. To which claim? You see the Rajesh PVC host path. That's the claim name. Did you see that? Now can I do that second one also? And second one is having 5 GB. Remember? Okay. And what happened?
In the name is same.
I think I copied the change, no? Sorry, my bad. I did not change it because I copied as it is. Yeah. So here pvc2.yaml, delete this and save it. Done. Can I create now? And guys, can I see the PV first? See, PV still available. Can I see the PVC now? PVC -n Rajesh. It's a namespace. See, pending. Why? Because I'm not getting 5 GB. I am not getting 5 GB. So guys, it's a pool. PV is a pool. PVC is the one which you bind it to the PV. Now this is a static I'm doing. Remember, dynamic will use storage class. Dynamic will be done depends on the storage class. Are you understanding this or not?
Yeah, getting.
Okay, so now what I will do, I'll just play a little bit of trick. One thing I'll do, I will modify this. I'll make it 1 GB itself. See what happens. And after that, apply. And see here, creation. See, it says PVC you cannot apply. The reason is spec is forbidden, resources request storage forbidden. That means field cannot be less than previous value. So this is a forbidden. You can ask for more, but not less. So what we need to do, we have to delete this. And last scenario is, can I create it? And created, can I see that? PVC both bounded and PV. Sorry, PV, no? PV. See? So now, did you understand the PV and PV concept, PVC concept?
Yes.
And now, let me tell you the last one, how to use it. So you know the PVC, you have to, here volume plugin will be PVC and claim name will be 1. So right now, if I see the PVC, look at the PVC, let me clear the screen here. Look at the PVC here, access mode, everything is there. Can we use it? Can we bind it? The binding is happen. So provisioning is happening. Binding is happen. I'm not to use it. I have to use it. Where to use it? This is how you are using. You know that. So I don't think so you'll get stuck on this because you have spent a lot of time on this. So here vi pod pvc.yaml and copy paste, done. Okay, and here I am going to create finally kubectl create -f this one and -n is equal to Rajesh, and here you got created and finally it happened. So now you see here you have used one of the PVC and you are happy with it. One of this, which one you used? I think I used first one. Okay, so this is the way you play with the PVC. Let me tell you guys, here only change will happen in this PV and PVC concept. PVC will remain same, pod will remain same here. This technology will change. So here this technology will change. Here this will be host path or integer or in NFS or EBS or Azure Disk or this or that. Those volume plugins which I showed you in the slides, it will be there. Physical storage will change. Okay, this is the static provisioning. Guys, did you understand that all of this?
Please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.